Hello everyone. Today on Geoscientist Voices, we are exploring the intersection of theoretical physics and the living Earth. My guest today is an unconventional and pioneering voice in the geoscientists, Professor Alan Hunt. Based at Wright State University in Ohio, Professor Hunt is a polymath whose work spans from the fundamental laws of percolation theory to the complex Gaia systems that regulate our global climate. With over 150 publications and a career that transitioned from theoretical physics to geology at age 40, he has spent decades challenging the status quo of how we understand water, soil, and life itself. Whether he is optimizing diaper design for industry or solving the water balance problem, he has puzzled hydrologists for a century. That has puzzled hydrologists for a century. He listened to the Earth through the lens of a physicist. Alan, thank you so much for joining me.
Thank you. Thank you very much.
So, I wanted to start with the period of your life that many in academia might be hesitant to discuss openly, because you spent 20 years teaching part time in physics before re-entering as a student in geology in the mid 90s at the age 40. Then, right before landing your tenure track position, you faced 6 months of unemployment. So, how did those unseen struggles and unconventional shifts shape you as a scientist?
Well, first, my dissertation advisor for a couple of years didn't have support, so I already started teaching part-time independently in 1980 before my PhD. Um, and I continued to teach part-time for 3 or 4 years after I was a reentry student in geology. And as you mentioned, I also had some other part-time or temporary postdocs during that period. It was a difficult period. It left me rather uncertain of myself in many interactions with other people or how to even proceed. So it had an impact. Um, However, in the scientific realm, after struggling with these kinds of problems for so long and you solve problems, then become committed. You learn how to become committed to getting them published um, in decent journals, although with constraints, like I couldn't pay page charges for any journal because of the lack of money. In fact, I didn't have a computer until 1998. The um, the final point you mentioned, the 6 months of unemployment, my wife characterized as like walking away from a plane crash when I got this job here at Wright State. So it has negative and positive impacts, but you're certainly never again the same.
Yeah, I mean, it sounds like it has been a real struggle. Uh, so, but you also had, it also added diversity to your life and career. And now I want to pivot to this sort of realm of your life. Because looking back even earlier, between 1985 and 1987, you were a Fulbright scholar in Germany, focusing on semiconductor physics. So, how did the scientific culture or the way probably of thinking you encountered in Germany influence your later transition into the complex, interconnected world of geosciences?
Uh, that's a very interesting question because the the most powerful influence I had was actually completely out of science. It was in the culture, but it was more an individual. I got married, and my wife was a art historian and still is, but she read novels by Agatha Christie, which are the famous novels about whodunit mysteries. And I read like 10 or 15 of these and never was able to figure out who the murderer was. But I realized in the process that one had to construct a hypothesis and see if the hypothesis fit the data. And the data were complex because some people lied, some people forgot important things, others didn't understand the importance of what they were seeing. And all of these characteristics are important if you want to solve the big problems in science, because data are collected that are inaccurate, that are reported incorrectly. In fact, in geology, you can read one should always emphasize the raw data and not the interpretation of the raw data, so that other people's understanding of the problem is not adversely affected. So these characteristics were important to me in sorting out fact from fiction and what was actually going on. And I think that surprisingly, that was what ultimately set my career on a path that was going to make some accomplishments. Because I wound up in 1998 when I met John Selker, who was recently president of the hydrology section of AGU. I told him, John, in looking at hydrology, surface hydrology is dominated by Bagnold, an engineer whose equations represent determinist work. And subsurface hydrology is dominated by stochastic subsurface hydrology. But this is backwards, because turbulent flow on the surface is it may be deterministic, but it's deterministic in a way that we cannot use the determinism for any practical purpose. It has large Reynolds numbers and turbulence, but flow in the subsurface has small Reynolds numbers. And so we should be doing this the other way around. And in fact, I think that what's really holding up the science of hydrology is a lack of application of percolation theory, which is appropriately designed to do it. So that was actually my guiding hypothesis. It's a crazy and oversimplified and almost stupid sounding thing, but it is proven to be incredibly useful. Because you can look at everywhere where there are problems in hydrology, it's because people do not know how to treat conductivity, they do not know what to do about heterogeneity, and they don't know what to do about scaling. In the surface hydrology, you get scaling laws from turbulence. These turbulence doesn't apply in the subsurface. I actually had a postdoctoral advisor who talked to me about eddies in the subsurface from flow. There are no eddies in the subsurface through the soil. It was just, but we were modeling it this way. And I eventually said, this can't be right.
Mm-hmm.
We got an equation out of it that was 50 pages long. And I said to him, Dirac said that all equations that are longer than one line are wrong. So that's what a perspective of a physicist brings. But again, it goes back to the idea that you have to develop some sort of some sort of guiding principle
Hmm.
or hypothesis, which is then going to connect in many different places to many different specific phenomena. And rather than trying to address little pieces of it at a time.
It definitely so, and I see that you developed your views with the help of also other people pretty early. And again, I want to pivot back to your to the 80s, which we started to talk about, like your time in Germany. And I'm really interested how the abroad experience shaped your vision, because I also had I earned my master degree in France, and I definitely inherited some of the traits of the French researchers, which I carry in me, like to this day, and use in every life in everyday science. So, given what you just told me about your percolation theory, your Fulbright stint in Germany, how did that affect your vision and the current state of your research, or maybe it was not as influencing as in my case was my 1 year stay in France. That's the thing that I'm interested in.
Well, in fact, interestingly enough, when I heard I was going to get the Fulbright, I just told everybody, I'll never teach part-time again.
Really? Why?
But but when I actually got the Fulbright, it displeased my advisor that I discovered that, I mean, I was slow. I'm a poor computer programmer, and it turned out I needed computer programming as well as analytical skills to do the work. Um, and it turned out that what he thought was going to cause a frequency dependent conductivity in these semiconductors at frequencies from kilohertz up to gigahertz
Mhm.
produced an absolutely flat response, and it didn't show up until close to 10 to the 12 hertz. And as a consequence, he wrote me a letter of recommendation, which said his most positive comment was that I enjoyed classical music. So I went back
Wow.
home. So I went back home and had another 17 years of part-time and temporary work.
Wow.
So for me, the experience in Germany was devastating. In fact, I got the percolation theory from my
Mhm.
dissertation advisor, Michael Pollock, who was cited in two Nobel Prize speeches in the 1970s from Philip Anderson, who is often cited among geoscientists for his comments about emergent behavior, and Neville Mott, who was knighted by the Queen. Um, so um, he was cited in particular in Neville Mott's speech for developing this critical path analysis, where you can use percolation theory to find the bottleneck resistance. Um,
Uh,
so I had a journey which actually had to go back to my advisor
mhm.
before I went on to other places, and but but in a completely different way. It was the German aspect was important because of my wife
Mhm.
and a broader understanding of sociology, art history, criminology, and so forth.
Yeah, I see the connection now. So I want to keep traveling back in time, and I want to ask you a question which is especially interesting to me, uh, because I also had like this spark, and I want to ask you about that. Was there a specific spark or a particular date, perhaps during your time at the UC Riverside, or even after your time in Germany, where the earth sciences stopped being just a subject and became your life's calling? At what age did you realize you were actually a geoscientist?
Now, this happened at Duke University in 1995, 96, when I returned at age 40 to get a master's in field geomorphology. But it was kind of latent for my entire life up until then because um, it turns out as a child between the age of 2 and 7, I spent summers at the Grand Canyon where my father was a seasonal naturalist.
Mm.
And for example, I can remember back to the age of 7 him pointing out to me the drainages on the eastern rim that were beheaded because they had originally, the streams in them had originally flowed downhill to the east when the Colorado River connected up and created a continuous flow path through the Grand Canyon, which I later published in a monograph on the Grand Canyon. I published about in 2001 before I got the job at Wright State. So, um, it, but at Duke, because I already had 35 or 40 publications in physics where I had addressed scientific problems of great magnitude, like the glass transition, I went to the colloquia. And I knew that if I had the right association, I could solve a new problem every week from each colloquium. And I vowed that I would get at least one publication from every class I took. And I only got 4 or 5 out of the 9, but it was that's when it really happened. And I was expecting, with all this background in the physics of disordered systems, to get out of Duke and land a job in geology right away. It also didn't happen. Turns out I was trained again for theoretical work, and the oil company people that were sent to Duke to interact with us were exploration geophysicists because they didn't regard Duke as a source for theoretical geophysicists. So that was another mismatch.
Well, the mismatching, it turned out pretty great in terms that it sort of also contributed to you becoming a uh, geoscientist.
Well, it was a great experience.
Mm.
Peter Mallon and I collaborated on the paper for Nature, where we showed that the Heinrich events, ice rafts across the North Atlantic, could be perfectly explained by the strain buildup in the crust from the ice sheets. Since the ice sheet was deepening linearly in time, strain buildups were quadratic, and the differences in strains uh, meant that the squares of the time of the differences in time should be equal for the Heinrich events, and they were. And then Peter found evidence of current seismicity around the ice sheets, including early earthquakes in the 20th century on Baffin Island of magnitude 8 from rebound. So so we got that published in Nature, and this was kind of I knew that with the right circumstances, we I could be collaborating with people to solve some problems of great interest.
Yeah, well, it's nice to hear that. And we talked about the spark and about the beginnings of understanding your geoscientific nature, if I may say so. But now let's talk about the difficulties, because looking at your own journey, transitioning fields at 40 and navigating the uncertainty of the job market. So, what was the highest friction point or the single biggest hurdle that you personally had to overcome to achieve the place in academia that you currently have?
Uh, to break into AGU, I came in from the side. I didn't have a mentor from AGU, so people didn't listen.
So
I mean, that's
lack of connections, like if I can interpret that in more
mhm.
simpler manner, right?
Yes. I was doing things as a physicist doing hydrology, and I didn't have a famous hydrologist to promote it. So I guess I presume that people didn't see the need to listen.
So, as a young scientist, I want to ask a question that what you're talking about has been certain like years ago. Looking at the situation in academia, in science now, do you think that this situation that you need a mentor or you need to be someone's protege or you need connections, does it still mean a lot in order for you to break through, to publish, to be accepted at certain societies, communities, circles, or is it like now more than you basically pave your own way to success? How do you think the situation is now?
Well, it's a complex problem. There is a lot of understanding of the need to embrace diversity in AGU, but each neglected community generates a group, a subgroup with spokespeople. And although I was 40 some years old when I got this master's in field geomorphology, um, and therefore far past any of the initiatives that are designed for beginning students, there was absolutely nothing supporting somebody in my position. I went to AGU in 1997 and 98, 99. Um, and I remember I could not even get an interview at the jobs board for a postdoc. With, in the meantime, 40 to 50 publications, including
Wow.
at least one in transport and porous media
So,
on hydrology.
so do you think that the situation changed right now, or scientists without like backing from someone more famous, they can or they cannot break through and get a job, tenure position or something like that?
Well, I mean, so I look at jobs just for the option to move up from, so to speak, from Wright State University.
Mhm.
And they talk about, of course, funding. They talk about networks, your service, your dedication to diversity. But when it comes to specific skills, there hasn't been a change. In the 1990s, when I was doing this, people were looking for specific skills with programs like ModFlow. Can you do ModFlow? And sure, join us. Now it's Stomp or some other smart cities, but you cannot find a pathway to a new job that emphasizes, are you generating new theory in the geosciences? It doesn't exist.
So yeah, like hard skills like being able to code in Python or know very well PyTorch or I don't know, using some other software is basically valued more than your creativity and ability to think as a scientist, as an inventor. Like if we talk about major university and tenure positions or just
Mhm.
positions in them. Oh, I didn't know that. I didn't think about it at all actually.
But if you look, I think that's what you'll see.
I'm not yet at the position to apply for such.
No,
Uh,
and don't look too soon,
yeah, yeah.
or you might be depressed. I
I
think, but
won't.
this is where the networking comes in. Your advisors will know precisely the people who are looking for the skills they are teaching you.
Yes, I rely on my advisors a lot, so I think they will be the people who would support me. So yeah, don't have
Yeah,
to worry right now.
I had two PhD students
Mhm.
while I've been here at Wright State. One worked on the weathering problem, and she's the first author on all those papers. I could not find her a job anywhere in the US. She went back to China and got a job there. My second PhD student had 30 refereed publications by the time he got his PhD with me, and was had refereed for 28 journals and was on the editorial boards of two when he got his PhD. But he wound up getting the Turcotte Award from AGU for the best thesis work in nonlinear geophysics, and he still had trouble getting a job.
Wow,
It's like,
frustrating.
um, and it's he 4 or 5 years later he got the early career soil physics and hydrology award from SSSA, Soil Science Society of America. Um, but when he tried to get tenure at Kansas State, his chair said, "Oh, I've already recommended somebody for tenure this year. You'll have to wait till next year." So a year or two after getting tenure, he went to University of Texas Arlington. He'd had enough. But there it's something that I've always worried about, actually, as a scientist, with all the emphasis on connections. Um, where is the value in the science? What if your resume, the quality of your resume and the number of your correct connections matter more? In other words, your presentation matters more than what you can accomplish and what you can help other people accomplish. Where's the sense?
Yeah, it's it's really a problem that, or let's say, um, something that we have to think about. What is really lying on the scale, whether your connections, your I think you have to have both. Rather, you have to. I mean, you have to have the skills and the thinking, but you also have to have connections because without that, I mean, people just probably don't trust people who they don't know or their friend don't know. I mean, it's life. We are social creatures, so
And what's happening now, of course, is where it started already when I was at NSF as a program director, and I knew a fellow named Praveen Kumar at the University of Illinois, Urbana-Champaign. And he became very interested in big data and how to extract signals from big data. Um, but with all the data gathering, now is the machine learning and artificial intelligence are threatening, in my mind, to remove the incentive to learn how to think independently altogether, because it's more important to learn how to develop the AI program than it is to understand what the AI is actually doing.
that's another thing I really wanted to talk with you about. But since you touched on this subject, let's get into this right now because I talked with many scientists, geoscientists, my colleagues, and somehow there is clear division where part of the people accepted that AI can help them and that now it's just impossible not to use it because otherwise you would be in the tail of the scientific movement, and the other part just totally rejects it. So I want to ask your opinion. is there a middle ground in terms of using AI? Like, can we still benefit from it and don't become a sort of black box scientist that just ask AI to give them new theory and they just apply it without thinking? Like can you comment on it? Like, can we be moderate in it, in this AI usage?
Well, theoretically, a middle ground exists. The question is, what do we know from each other as human beings, social beings, and the nonlinearity of our interactions that can help us predict what actually will happen? And I, I don't know. I think that the group that's going along with AI is deceiving itself. There's a great play called Rhinoceros by Eugene Ionesco, where people start turning into rhinoceroses because it's fun. And there's no way back, and pretty soon there's only one person left, and this entire city, the region, is not a rhinoceros. But so that's a sociological question. But I mean, we have enough observation to predict what will probably happen. I think it's not a good outcome.
So you think that it's mostly a negative effect of the machine learning and AI that we are experiencing right now, rather than something that advances our science?
Well, I had a communication with Solomon Vimo.
Mhm.
You might know him. Yeah, I think he's in earthquakes.
Sure.
Vimo, Solomon Vimo, Vimal.
I've heard his name. I don't think I. Maybe I read his papers.
Mhm.
I don't recall exactly which ones, but I don't know personally for sure.
Well, anyway, he wrote to AGU, the Hydrology Digest, or the AGU Digest that comes out every day, and he talked about this conference with AI and how he also had these ideas. I mean, he wanted to include people in the synthesis of AI with other things, and I couldn't take part again because I don't do AI, and I won't. I might use some results that other people get from AI at some time, but that's it. Anyway, he bragged about the number of citations that one of the papers at this AI conference had that had been published like 3 years ago. Already had 220,000 citations. I wrote him, that sounds like a Russian bot
Yeah.
that's influencing our elections. And he wrote back that Praveen Kumar had given a talk at same Praveen Kumar as before at the conference, which said that 200,000 was actually too few. I'm sitting here thinking, well, look, I solved the water balance. That gives me the carbon cycle. That gives me the global temperatures. It gives me species richness. These papers are written up in AGU Advances in EOS and by the editors of Ecological Modeling to me. And as you know, Mark Brandon from Yale wrote about the success of the chemical weathering part in a completely unsolicited uh, thing. And cumulatively, these papers maybe have a couple of hundred citations out of my 7,000 citations. And they're telling me 200,000 for this conference is too few. Well, how many should I be having then? It's certainly not just 10 or 20 a paper, half of which are my own. This is nonsense.
Yeah, it sounds a
Richard
bit
Greenwald
crazy.
wrote the same thing, that what we are doing is more fundamental and better long-term accounting of the water balance than Boudica or anything they or anybody else had published. And Mark Brandon wrote the same thing about the chemical weathering. And these are unsolicited emails. So I don't understand the ability of people to follow a bandwagon. It's too much. But given that, then I can only say I expect it to continue and just worsen because, as they say, there will be no place for people who don't do it.
Yes, for the good or for the bad, I think you are totally right, and it will definitely continue to be developing. But I really want to move back to your scientific work, and you partially addressed it in the beginning of our conversation. But anyway, I want to ask you and underline that you've moved from the world of theoretical physics and semiconductor research into geomorphology, as you said, and hydrology. But in your view, philosophically and science wise also, did you ever truly leave physics, or did you simply discover that the Earth's surface is the most complex and fascinating laboratory for a physicist to work in?
I'm I'm afraid that that is a very succinct summary of what I did. Yes, I mean, and I can give you another example from Duke. I met Oren Pilkey there. I took beach and coastal processes from him. He's got 30 books on beach and coastal processes. He said two things to me. He said, Alan, all models are wrong. So there's, I don't trust any model. And the second thing is, we've got to teach you to stop thinking like a physicist and start thinking like a geoscientist. Um, that is a kind of sectarian thinking that's false. I agree that you need to develop new ways of thinking too. So in geosciences, the idea is you develop a hypothesis and you test it. In many physics problems, you simply use the most suitable mathematics for a given problem. If you have a rocket, you don't use conservation of energy, you use conservation of momentum. If you know that you learn about what the fundamental science is behind something and you focus on that particular approach. Um, it seems to me that if you go from physics into geosciences, you need to learn how to make hypotheses and test them, but you don't use an inappropriate mathematical technique to derive your equations. If you do that, then instead of testing the success or failure of your hypothesis, you're testing the appropriateness or inappropriateness of your math, and you don't know what may be causing the inaccuracies. It may be your method of solution. If you do that, then you've invalidated your entire research. I watched somebody, Stuart Loistacher, was a master's student, and they were using linear response theory to deal with which in hydrology is known as the unit hydrograph, as the Green's function from physics. He was using this Green's function theory to interpret the changes in the architecture of the subsurface after the Santa Cruz earthquake in 1993 or 1 or whenever it was, the 7.3 earthquake between Santa Cruz and San Jose. But his water table depth was 100 meters. And, there is no linear response theory in an arid region where the water table depth is 100 meters. Actually, I found out that you can do that too, but you have to do things like account for changes in storage. and use linear response basically over a period where there is no change in storage in the shallow subsurface. But in some places, that condition will invalidate linear response for almost every period you try to look at it. And I mentioned this to him, and he said, "Yeah, well, of course I knew that's true, but we had to use something, you know." Sure, you have to use something, but if you know it's not appropriate, then perhaps you should go about trying to find out what is appropriate first,
Sure.
instead of rush off to generate a solution, because you don't know whether the linear response is whether it's an artifact of the linear response rather than an actual change in the architecture.
Yeah, it's an interesting question, and it's interesting how you interpreted uh, the, um, the research and based on the question that I asked. And you also mentioned earthquakes, and in our previous conversation with you, you mentioned that Bill McGuire credited your work as the inspiration for his book Waking the Giant, and you show that tiny environmental changes, the sea level drops and ice loss, which you also talked about previously in our today's conversation, so they can trigger earthquakes. So, from a percolation perspective, is this just a case of an environmental nudge pushing the system past its connectivity threshold, or it's something else?
That's a hard question, um, but it's a um, it's a valid question. I think in the case of the ice sheets, it's not just a nudge, okay, because they were 10,000 feet of ice on a continent. But in the case of the 30 centimeters sea level change reduction pre El Nino, which triggered higher seismicity and heat flow in off East Pacific rise, that could be just a nudge. That um, now percolation theory has nonlinearities, which allow, in principle, a passing of a threshold. So possibly, I never thought of it in those terms, so I can't say. I don't. Um, it's a question of. It would be a question, I believe, of is there a minimum threshold for any seismicity changes? Like, is it 5 centimeters of sea level change, 30 centimeters, 60 centimeters? Um, or does it just have an effect on smaller and smaller length scales in the crust below, and time scales, like micro earthquakes, fractures of rock, of like handheld size fractures of rock? And I don't know, because I don't think that the community has taken that issue as seriously as it would need to in order to figure that out. It's I have a collaborator, DJ Sornet, who works with the other end of the deviation from Gutenberg Richter. He calls them dragon. Uh, I forgot about dragon, something dragon statistics, where he says that in fact, um, you like in cities, um, the largest city in France and the largest city in Britain are so much larger than the next larger cities, Paris, Paris and London, that they don't fit on this kind of a hierarchy. they're off the charts. You could not predict them from Gutenberg Richter or any analogous power law. And it's because in those cases, the political and the banking or economic hubs have been in the same places for centuries, London and Paris. So from the perspective of a geologist, these are like uh, out of the physics or statistical realm and in another realm, although Didier likes to try to predict these things too across financial crises and so forth, according to statistics that are beyond my understanding. But so you can look at you can look at these statistical laws like Gutenberg-Richter, which hold from maybe magnitude 2 up to magnitude 8 earthquakes and then aftershocks too. But it's not clear that they hold off the ends of those scales, and so it's not clear whether. I mean, in the one case, they can be truncated, but then you have these special cases that are well off the edge. And then the other, and is that a matter of not having enough statistics to tell, or is it, or what? And the other edge would be someplace in this case where I don't think anybody's really compiled the statistics. As Bill McGuire says, these are tiny environmental effects, but they nevertheless add up. And when the ice melts off Antarctica and Greenland, there will be major seismic episodes because you cannot remove thousands of meters of ice without having strain rates sufficient to create magnitude 8 earthquakes.
Yeah, it's really a topic that fascinates me. Basically, can we say that because these effects of reduction of the ice mass that they can cause seismic uh, activity, can we like say in a wider perspective that climate change basically causes seismicity? Can we elongate this? Can we make this frame wider and make such an assumption that one causes the other through certain indirectly connected steps and events? That's like a domino effect.
Well, there have been more recent suggestions like this. For example, um, the idea of what stopped Snowball Earth, um, because that's one of the big problems of understanding the Earth's climate system. These are pre-Phanerozoic. I don't deal with them directly, but so I read an article in the last 5 years where people suggested that in fact the the removal of essentially, I'm not sure. I'm not sure about the context, but yes, the change in sea level from global and continental ice sheets could change volcanism along the Atlantic and other mid-ocean ridges sufficiently to increase the outgassing of carbon dioxide and provide a negative feedback for the climate change, in addition to the one that's provided by the weathering, because you have um, very little land surface exposed to water, which is essential to carry reaction products away from the weathering zone. You, and without which weathering ceases. So you have various candidates here, and some of them can involve seismicity and volcanism for the and we mentioned some. Bill has mentioned some, and others have mentioned yet another one, like the level of sea level, the elevation of sea level, and the volcanism along the ridges. So these need to be sorted out, and I don't know how Bill McGuire sorted out our proposed effects from sea level, but he said they claimed that our hypothesis was validated in his Proceedings of the Royal Society
Yeah,
article.
that's really. I mean, thank you for commenting on it because I got interested in these sort of connections, how climate change can basically affect something that people and common public don't even think about. And I think that after listening to like what you say and your interview and just you reviewing the recent scientific articles, I think that people would understand how drastic is influence of climate change into those aspects even of life that people have no idea that they are being touched by this like global phenomena and drastic change of climate. So
Can I mention one other uh, little occurrence recently? There was somebody from Italy who wrote to AGU and on one of these discussion boards, right? The Hydrology Digest, I think, but I think it must have also been to AGU
mhm.
in general. And he was interested in the Messinian crisis in the Mediterranean and
Mhm.
how it would have affected the volcanism. Because if you lose 5,000 meters of water in places, then that changes the crustal stresses enormously. And I told him you should talk to Bill, send him to Bill. And Bill said, well, unfortunately, I'm retired, but send him to somebody else. So if you go back and find that, you will see that um, that these are questions that, when you start to think about them, they're not confined to a single episode or a single thing. I mean, we have fracking, we have reservoir changes, um, you know, built up cities, maybe. I mean,
Yeah.
certainly we have subsidence from extracting groundwater, but um, we have lots of difficult to explain earthquakes. And by the way, Arch Johnston, when I first approached Peter Mallon with the article about the Heinrich events, he said, oh, we try to publish this, we're going to get killed by the seismologists who just don't believe in it. And that summer, I went back to California from Duke um, over summer in 1996. And in that summer, Arch Johnston published an article, and I think somebody else published an article on the Fennoscandia scarp, which was 100 kilometers or 200 kilometers long and 2 meters high, and attributed it to isostatic rebound. And I said to him, "Look at this." And he said, "Yeah, I know. I saw it too. I was thinking of you." Yes, and we can go ahead and try to get that article published about isostatic rebound being not merely aseismic, but coseismic as well. Um, so it's these kinds of things are happening all over the world
Yeah.
for a variety of causes. Um,
Yeah, it's interesting. Yes, it's never thought
and whether
actually
there are
about that a lot.
and whether there are thresholds that have to be passed, or whether the is simply a scaling relationship between the strain and the magnitude of the earthquakes that result, that might even be linear. I don't. I think a lot more research has to be done. and I'm pretty sure it's still a pretty new field.
Yeah, uh, I agree with that, and I want to keep talking about your research because, but a bit from other side than we talked about now. So in your university profile, you mention research products as diverse as chemical weathering and optimal diaper design for Procter and Gamble. So many see this as completely unrelated worlds, but you see them through the same lens. So is there a fundamental language of moisture that ties these industrial and geological problems together?
Well, that's fascinating too, because um, I, the yes and no. It's optimality. Optimality is involved in both, but not necessarily in the same way. Um, so looking at it from different directions, that's another thing which was important to me is being able to incorporate other perspectives. For this, I was called on to look at Adrian Bayon and constructal theory, as he calls it, which is an engineering optimization. But he calls it constructal because it starts from the crossover between diffusion and advection in moving fluid around,
Mm-hmm.
which all uh, large animals deal with. We have a blood circulatory system and we have diffusion of nutrients across cell walls. So you have the problem with diffusion is while it is extremely efficient at small scales, it's extraordinarily inefficient at large scales. And if you were to rely on diffusion to get your meal to your extremities, it would take years. So you couldn't be very active in the meantime. So we rely on the heart, which pushes the blood around. That's the advection that moves the things. The diaper design was an optimality, and the idea was to solve a partial differential equation, like a diffusion equation, on a hierarchical structure. Fortunately, I only had to go to level 2 because um, that's for me would have been out of my capabilities. Um, but optimality is involved, and we don't know in which ways optimality is involved. Beyond says that all living and things and structures that last must get more efficient with time. That's the way he views constructal theory. Well, for river networks and tree roots and soils, we postulated that the optimal paths exponent from percolation theory would be relevant. And this was even by itself a complicated suggestion because if for roots cannot possibly know the optimal path between point A and point B. So how do they find it? If that's what they're doing. And our idea, this was in a book that I wrote with Stefano Mansoni, that collaboration came to the conclusion that the only way to understand that is that the roots suck water out of the soil, and the water, because it is flowing through a connected network, does find the optimal path. Through, I mean, it finds all paths, but it is dominated by the optimal path. So if a root is pulling on water, it's going to grow back up the optimal path because that's the one that is supplying the largest amount of water and especially if it happens to intersect with a nutrient source, the largest amount of nutrients too. And it gets this extra benefit from having the least cumulative resistance to growth through it, because by the same virtue. Now, here's where I think the physics perspective really helps, because if you look at the power involved with the optimal resistance from the perspective of applying the potential, V squared over R is the power, and that is maximized. So the dissipation along those paths is maximized. But if you look at the power from the current, which is determined by, how much mass you're trying to shove through, that's I squared R. And that power is minimized. So the plant gets the most response out of the medium by giving a minimum amount of effort and the minimum amount of creation of entropy within the plant. But it actually has a maximum creation of entropy within the medium, which is what living things tend to do. So I talked with Hubert Savigny, former, I think, president of International Association of Hydrologic Sciences. He gave a seminar here, virtual, and he's firmly of the belief that you can, and he works with Axel Kleiden, that you can find the water balance and such things by applying maximum entropy creation. And we're looking at it from the other, and they're looking at it from the atmosphere. We're looking at it from the soil. In the soil, we're applying minimum entropy, minimum energy production, basically, and maximum growth rates, because plants are going to want to grow as fast as they can to prevent other plants from being able to compete for resources. So this underlay part of our work on the water balance. And interestingly enough, Clyden's result for the evapotranspiration in humid systems was that ET is a constant fraction of the potential evapotranspiration. And that fraction does not go to 1 in the limit of the maximally humid system as assumed in the common Boudico and virtually every other phenomenology. But ours also didn't, because we said the plants want to give some of the water to the soil so that there's soil. Otherwise, there's no soil to grow in. And we got the same result. It was a constant fraction of the potential evapotranspiration. And then when we compared those results with Gabi Catul's advice from Duke, we found that they had the fractions were the same for our shallow roots, 2D, when the temperature was 15 degrees C, and for the deep roots at 33 C. These two temperatures span all the ecological optimality temperatures seen on Earth today, and they also constrain the Phanerozoic temperature fluctuations. Almost never goes over 33, and if the global temperature goes under 15, you get an ice age, and you get rapid fluctuations along the Milankovitch cycle, so it gets really unstable. And the entire interpretation turns our understanding of climate change sort of on its head. Water and plants are making the climate warmer and preventing us from having ice ages, provided the plants can keep the temperature within 15 to 33 C.
So I wanted to pivot to this topic as well, because I want to talk about your recent research because you've recently focused on the Gaia hypothesis, the idea that life basically, as we've been talking about, regulates Earth's climate to its advantage. And your 2025 research suggests that it takes approximately 60 to 80 million years for a synergistic system of plants and soil to return the Earth to homeostasis after a major climate shock. So, does this massive time scale suggest that the Earth has a memory? And if so, what does that mean for our current climate crisis, which is moving at a much faster pace?
Well, um, that's a different perspective from mine. It's the lack of a memory which caused that, but that requires a little bit of detail.
Mm-hmm.
So these climate shocks were created by the plant's invasion of the land. And particularly the second one was nasty because between around 420 and 380 million years ago, plants invaded the land and started to grow tall and create deep root systems with a lot of wood, hard wood. And the shock was that this increased the oxygen level in the atmosphere from around 6 or 7% to 30%, and thereby reduced the CO2 level dramatically. What now took the time to return it to equilibrium was a combination of two things. One was bacteria and fungi developing synergistic ways to decompose the wood. If you look at that period, you'll find it's when the huge coal beds were deposited in the Mississippian, well, the Carboniferous, and to some degree, how long it took that entire clade of the complex biogeochemical cycle to spread across the continents. Because the innovation in one area doesn't, especially if it's synergistic between bacteria and fungi, doesn't produce the innovation everywhere all at once. And if you look at diffusion, you find that even birds nowadays, if you take a look at how fast they diffuse seeds over a few years, getting acres or even hectares in the square kilometer, maybe, if you extrapolate that to 5,000 or 10 million square kilometers, you find it takes like hundreds of millions of years just by pure diffusion. Diffusion is inefficient at large length scales. So we took our vegetation scaling relationship, which we tested for root tip extension rates and, tens of to hundreds of microns and shoots at months to 100 years or 200 years and clones up to 100,000 years for vegetation growing through the soil along these optimal paths in conjunction with the bacteria and the fungi that synergistically help the roots or with their own synergy help to decay the roots. If we put in 5,000 kilometers, we got 60 million years to 80 million years. So we published that, Stefano Mansoni and I, in that book in 2015, but we didn't know what to apply it to. But we said this would be a time for a guy, a superorganism of interacting ecosystems to form. But when we looked at the temperature record more recently with my colleagues, and we published this article in Vadostone Journal, we found out that it really made sense to apply it to the periods following the initial invasion of the land by plants, 480 to 500 million years, and the second one, 380 to 400 million years or so. And we found that each time the recovery, which is also measured by the ratio of oxygen to CO2, took about 60 million years. So after 60 to 80 million years, the recovery occurred the second time, and the temperature and the CO2 just gradually rose all the way towards the end of the Permian when the Siberian traps erupted and produced this enormous injection of CO2. And a Pangea, which had huge areas without much water, and a very difficult way to reverse that by chemical weathering, precipitating a crisis. So we began to understand the entire evolution of the climate system.
That's really fascinating how we did that, and your recent article is like a huge thing which is directly relates to the current situation and really gives perspective on what we see. It's,
Well, I think I can now say why. I also think we can now say why we even fell into another ice age, despite the unfavorable positions of the continents. About 10 million years ago to 8 million years ago, C4 plants started to become really important.
mm-hmm.
And what they do is they take carbon dioxide out of the atmosphere without putting nearly as much water in, because they are very much more efficient in drylands. So water is thousands of times more effective as a greenhouse gas, and it's also thousands of times more prevalent. But any change in this balance tends to drive you towards dryness and coldness, because you're getting more carbon dioxide drawdown for less water, and it doesn't even matter whether your plants can still be biodegraded or not. So that's another important innovation from the biosphere. And who knows what the Earth has developed as a response? Perhaps humans
So
to take down some of the previously sequestered carbon and use it to keep the carbon in the atmosphere. But maybe, the Earth didn't do that. We just happened.
So do you have a firm position? Because I recently had the discussion with the why internet with fellow geoscientists and just scientists, and some of them think that basically the big like greenhouse effect and the rapid climate change. I mean, both of them agree that human factors are responsible for it, but one part think that its human factor is critical in driving our planet to basically hotter climate and to like the negative side, and the other thing that human factor is not that huge in it, and basically planet itself drives us to global warming. So do you have a firm position on it that what would you choose among these two options, and maybe you have a third one that I didn't talk about?
That's difficult because it requires more competence than I have yet. But from looking at the long-term temperature trends, the Earth is cooling off despite having lower oxygen levels that it had at the end of the Hernantian Ice Age, this one in the from following are associated with the end of the Carboniferous before we went to the heating. Oxygen levels reached 30% at that point, and now they're 20. My opinion is that indeed, without, I mean, the timing's right. The cause didn't change in terms of C4 planned innovation. I think we'd be in another ice age now without human intervention. This feedback is extraordinarily strong. You freeze vegetation, you store the carbon in bogs. The atmosphere gets drier, it gets rapidly colder. Things were going very badly for humans in Northern Europe in the 16th, 17th, early 18th century, 18th centuries, and early 19th. And probably elsewhere too, glaciers are expanding. So I think we were going right back into another ice age. It's not the planet's doing, it's ours. However, on the other hand, vegetation can do pretty well. And the animals, the animal groups do pretty well over a wide range of temperatures from 15 to 30 or so C, 30 up almost to 33 C. So is the Earth in trouble? No, but humans are. We're notoriously bad at we're notoriously good at exploiting opportunities and notoriously bad at planning for crises. I think our response is inadequate, completely inadequate to what we're doing to the planet, and it's looking like it's having less and less of a chance at all times. I'm not at all worried for the planet. I'm just worried about the number of people who have to move from regions that become uninhabitable or for too high temperatures, or for which agriculture doesn't succeed, or where the sea levels interfering with and this is coupled with all the degradation of the environment too. So yeah, I think it's a true crisis for humanity. It's
But you
not
s-
for the planet.
but you said
And
that
it's caused by humans too. And it is caused by humans. I believe that, but that's a belief.
But you said that if it weren't for humans, we would be in an ice age, right? So
Yeah.
what is better, being in an ice age or being in the like on the road to crisis that we are having now? So is there
Well, we can
any?
turn back from that a lot more easily, I think, in principle. But we need to get away from misinformation somehow, and political manipulation for the benefit of the wealthy. But these are obvious, right, to most geoscientists.
Yeah, I want to mention that in one of my previous interviews, I spoke with my friend and geoscientist from Canada, and we talked about the human factor in climate change, and he gave a really good reasoning why, like, is human activity basically is driving our climate to the direction where it is going to, and then uh, soon after I uploaded this interview on YouTube, like my channel was temporarily blocked, and then it has
Mm.
been reinstated, and I made a pretty decent search and talked with other people, and they said that basically AI, which YouTube uses, it saw the conversation about climate change, global warming, and stuff like that, and so it basically automatically tagged it as if I am or my guest disseminated disinformation, and it blocked it, and then it gave it to a human reviewer, and the human reviewer flagged it as a relevant scientific information. So what I'm driving at is that this topic seems to be so dangerous that YouTube algorithm, I cannot say for sure again, but it's a belief based on what I read. Basically, it turned it took down my channel for a couple of hours, the entire channel and all the other interviews, just to review if what I'm talking about, or my guest, who is a doctor in geosciences, is like if we are not spreading some dangerous facts. And we didn't talk about violence or something like that. We just talked about for 5 or 7 minutes about what we are talking right now. So basically, this topic is more dangerous to talk about than some other like
Yeah.
explicitly violent topics. So it's just
Mm,
wanted to say it.
that's an example of some of the unpredictability of AI too,
Yeah.
because people program it for different purposes and they're not sure what they really don't know how it's going to perform. There was a point, for example, when somebody asked AI about a question about Musk, and the AI gave an extremely negative answer about Musk's impact um, on the government, I think. But I think it's dangerous. It's just more confirmation of what we already talked about. It's kind of an interesting circle to complete.
Yeah, it definitely will give me thought, like food for thought, and our viewers as well. But talking about our viewers and talking about the audience that we will give this conversation to. So based on your non-linear career, what is one life hack or soft skill that today's geophysics or geological students often overlook, but which is essential for surviving the non-linear pressures of modern academic career?
It's not a hack or a skill. It's he, this brings me back to your first question. One other thing my wife told me was she quoted Schiller, Friedrich Schiller in German. And I'll say it in German because anybody who speaks German would recognize it instantly as Glück hat auf Dauer nur der Tüchtige. It's good fortune comes only to those who persist. Good fortune with any long-lasting effects comes only to those who persist. In my case, I had to persist for well over 20 years. I don't want to send anybody on such a path, but everybody's going to have to make their own compromise between what seems to be expedient at the time and what seems to that person to be best for the future of science, the world, and the person in the world. And these compromises have to be made. And I made some too, but I didn't make very many. And the more compromises you make, perhaps the less barriers and pain you experience on the way. But you have to decide what risks you can afford to take and which you can't. So this is not really advice. It's not a hack, but it is sort of another optimization process. How do you live with yourself and yet live? They don't always cooperate.
I think it's really a good point that you mentioned here, because making compromises, like in science, I think you have to make compromises. If you have co-authors, you have to compromise on the content of the paper you put out in the world. But I think it all depends on our internal compass, like moral compass. It's like where is the line where sort of end justifying the means, like whether you, I don't know, if you have to choose between putting out in the world your research and making compromises which would probably you know, pinch you as something that you wouldn't do. I don't know. I think, I mean, if you go to science, you'd have to make a lot of compromises in terms of also personal life, maybe, where you have to skip your, I don't know, close one, your loved one birthday, I don't know, to go to conference, stuff like that. So it's
Yeah, sorry.
yeah,
But let me give you an example.
yeah.
My former student, name him Bazad Ganbarian, you can look him up. He's going to pass me in a couple of years with his H index. He published a paper on thermal conductivity and invited me to be an author on it. And there were a couple of other papers, and I turned it down because I did not completely believe in it. It's one of his most cited papers and has gotten him huge amount of attention, invitations to Japan for months and so forth. And I could be wrong, but I didn't completely believe in the approach. So I said no. My own dissertation advisor, I know, did that with me on a paper, but I'm pretty convinced he didn't listen carefully enough.
So do you regret about it?
Maybe.
Like you like that you missed out on an opportunity to get bigger exposure in the scientific world, or you
No,
still
I don't regret it at all
you don't?
because it was his idea. He took a somewhat different path, and it's just perfect. If if it really does deserve the additional credit, then he's the one who deserves it. And if it doesn't, then I don't have a problem. I didn't have any conflict with myself, like I say. And if it does, he reaps the benefit. So it's the right way to go. That one I could identify, and in retrospect, I don't have a problem with it.
It's interesting. Thank you for sharing such a personal story, personal moment. And on this personal note, I also want to ask you, can you describe your typical daily routine, like between writing about Paleozoic temperature record and mentoring the next generation? Do you still find time to get your hands dirty with the raw data, the code, and like, do you start your day with I don't. I know that you don't start your day with AI, but do you start it with the coffee, tea, or with the I don't know, new papers you find on ResearchGate? Like, how is your day structured?
I, Unfortunately, the things I do most often are eat breakfast and look at the games in the New York Times, like spelling bee.
Oh,
um,
that's a good start.
I'm 71 now. I don't deal well with a 16-hour day anymore, but I do tend to work on weekends and in the evenings too. But working is it's mixed. I'm reading articles sometimes. I'm following up ideas I had. I'm thinking, I've read someplace such and such and I can't find it. How do I find it again? I need to refer to it. or my two students have some new ideas they want to explore with me. I have to teach in the 2 hours before I did this interview. I wrote up a a case supporting somebody's application for full professor because I'm chair of the college promotion and tenure committee this year. Or I might be trying to get a sabbatical or find a better job in another place. I'm intensely involved with work, but I can't sustain the kind of things I used to do, where I would write 14 papers a year on my own, submit 11. I get 11 published uh, from pure theory. Those were 20-hour a day work days. You can't do that anymore when you're 71. If you do, you'll wind up in the hospital within a few months.
Yeah. Oh, well,
So I
that's
don't have any I don't have any really hard and fast habits. And I do try to meet the needs of my close family and students and so forth. University too.
it,
Different every day.
it's pretty busy anyway. Like what you said, it's like working on weekends. It's pretty busy, but I want to steer to the sort of hobby realm of yours and specific realm. Outside of the world of percolation and hydrology, what do you read or do to disconnect? Like, uh, do you find that your interest outside of science, perhaps in philosophy or literature, inform your theory building? Maybe the games you're reading about in the newspaper, like, does it help you in your science anyway?
Not really. The one thing I try to do regularly is get exercise. And in the
Good.
winter in the Midwest, that's hard, but um, I do like to hike and ride a bike. But I live in Ohio, so there's no canyons, no decent canyons. So I don't know. I still love the Southwest with its open exposure of geology and beauty.
So, as a man who has seen the geosciences from both the perspective of a theoretical physicist and field geomorphologist, in just one word, how would you describe the future of the geosciences?
Well, I can give you several words and you can choose between them. Rich, fraught, complex. So uh, one word is impossible, of course, but um, probably complex is best. But the other two, I mean, what complex is neutral, rich is positive, and fraught is negative. It can all essentially mean the same thing.
Yeah, I totally agree with you. So, Alan, thank you for your honesty and your deep commitment to fundamental science. Your journey reminds us that the path to discovery is rarely a straight line, but the nonlinear routes often lead to the most important destinations. So, thank you so much for talking about it and to share your experience and advices.
Thank you for having me. I've been wanting to share this. And I think to me, it's so important to try to be honest. I mean, we all have our places where we're limited, but you have to try, do your best. So otherwise, what you tell people is not worth anything.